Hey, thanks for joining me. So today we're looking at a Hackerrank problem called inserting a node into a doubly linked list. And it's a part of the practice interview prep kit, and it's grouped under linked lists if you want to check anything out while going over this problem. So given a reference to the head of a doubly linked list and an integer data, create a new doubly linked list node object having data value data and insert it at the proper location to maintain the sort. So we're given an example here. The head refers to the list 1, 2, 4, null, and we're given data equal 3. So again, we're given a head reference and a data value to insert in a sorted doubly linked list. The thing that we need to return is the doubly linked list node pointer. That's the thing that we'll be going for at the end. So just some things to consider. One of the first things that comes to mind, what are the cases we need to capture? And we had an example here. It gives us a nice start. We insert 3 into a sorted doubly linked list. You can see in the example I have here, starting out with 1, 2, 4 in our list, and then we insert 3. And I like to include the example so we see our pointers. And we see off on the outside, or excuse me, on the next line, we see what's been inserted, just to hopefully help make that clear. That's the one thing, or excuse me, one of the cases that's fairly clear. What we could also do is we could have a few edge cases. We could insert also at the front of the list and have a new head node. We could insert at the end of the list, and then we could also handle a null case. So just to look at this a little bit, to make things explicit, one of our edge cases we could insert at the front of a sorted doubly linked list. So in this example, let's take a look at a list 2, 3, 4, and then insert 1. Here we can see that our new node 1 will have to point to null. And then we'll have two-way pointers between 1 and 2. We have one more case, one more edge case, where we could insert at the end of a doubly linked list. In this example, we will insert 4 into a list of 1, 2, and 3. So we would be inserting at the end with 4. Here we can see 4 is appended to the end, and there should be an arrow, like so here. Apologies for missing that detail. And then 4 will point to null. And then we have one last case. In almost all instances where we're looking at some type of node system, whether that be a tree, perhaps with graphs, I don't have a ton of experience with them, but for linked lists as well, we handle a null node case. So if we're handed null, we'll have an empty list, and we will insert 2. In this example, we insert 2, and then have pointers to null. So that will basically be our whole list. So let's take a look at some code. How would we implement this? And here is our function, sorted insert. And remember, we'll be trying to return a doubly linked list node. So what's the first thing that we want to do? Well, we'll want to create our new node. And then we'll evaluate our null node case, our null head. In that case, we'll just return the new node that we created. In the event that our head node is not null, then we'll use a two-pointer system to evaluate things. We'll have our current node equal to the head node, and then we'll also make a previous node. And how would we initialize that value? Because current is equal to the head, what would be previous of that? Nothing. We would just have null. So that's why we initialize it as null. Just a quick question here, or something to think about. Why would we have our current node? Why wouldn't we just use head? Well, as we've mentioned, the doubly linked list node that we're supposed to return is a reference to the head node. So in this way, we're keeping track of what our head node is. and we'll be able to return that at the end after we've updated the list. This is just a way using current to move through our linked list. So what's the first thing we're going to consider? We'll consider one of our first edge cases. If the value that we're going to insert is less than the current value of the current node, we're going to insert our new node at the front of that list. And the first thing that we'll do is create pointers, or we'll update pointers. Our new node's next node will be the current node, which remember is the head node currently, because we haven't done any type of update to it. It's still just equal to the head node. As this new node will be the new head node, the previous node will be equal to null. Then we'll have to update the old head of the linked list, and we'll make that equal to our new node. As I've mentioned a few times here, now we have a new head node, and that's what we're supposed to return in this problem. So we return our new node. Assuming that the inserted value is not to be inserted at the front of the list, we then look at this code where we evaluate if our current node is not equal to null, and if the inserted value, or the value to insert, is greater than the current node's value, we then move through the list. And we make our previous node, which is initially set to null, equal to the current node. And then we make the current node equal to the next node. And in this way, we increment down the list until these conditions are met or not met. One of the reasons we may exit the while loop is because our current node equals null. In that case, that means we've reached the end of the linked list, and the last node in the linked list is actually the previous node, is our previous pointer. In that case, just as before when we added our new node to the front of the linked list, we want to make pointers at the end of our linked list. So the new node's previous node will be the previous node, which is the last node in the linked list. And then the next node for the new node will be pointing to null because it's now the end of the list. This means we just have to update previous.next to be equal to our new node. Here we can then return head, or actually we don't need that line there. In the event that this is not equal to null, then we catch all of the other conditions here, and we're actually adding a node inside. We're inserting a node somewhere inside the linked list, not at the front, not at the end, but somewhere in the middle. In that case, we need to again update our new node's pointers just as we've done in the other cases. We make new node.previous equal to previous node. We make the new node.next equal the previous.next node. And then we have to update the previous.next node to the new node. And here is the most tricky part of the entire algorithm, in my opinion. We want to make the new node next node what that node was pointing to, the previous node that it was pointing to needs to be changed, and that needs to be pointed to the new node. At that point, we can return the head, and we can run our code, which I'm not sure if you can see me press the button down here, but I have run the code, and all of our cases pass. And let's submit this so you can see that indeed all of the cases do pass. And there we are. All right. Well, thank you very much for joining me. This was a pleasure.